Welcome once again. Today we will discuss about multiple linear regression model, right? Multiple linear regression model that we are going to discuss today. This is multiple linear regression model. Now, so far whatever econometric models we have discussed, they are called two variable linear regression model. What does it mean? That means our model was something like this: yi equals to alpha plus beta xi plus ui. This is called two variable linear regression model, or you can write CLRM kind of thing, two variable CLRM, classical linear regression model. Why this is called two variable? Because you have one dependent variable and one independent variable. That is why it is called two variable linear regression model, right? And as for example, you can think of y is your consumption expenditure that you are going to explain by your income, right? Now, let us say that today we will take another example where our objective is to, let us say, estimate returns to education on wage, right. What is our objective? Objective is to measure returns to education. So, basically what is the impact of education on your wage or salary, right. So, let us say that our model is now wage is dependent variable for the ith person equals to some beta 0 plus beta 1 education plus this. Okay. This is our objective, to estimate returns to education. So, obviously here your beta hat would tell you for a unit change in education what would be the additional change in wage on an average. So, beta hat will give you returns to education, beta hat will tell you returns to education, beta 1 hat, right. This is called returns to education. This is the model we have learned so far. This is also a two variable linear regression model kind of thing, because you have one dependent variable, one independent variable. Now, when we think about multiple linear regression model, first of all we need to understand why do we need multiple linear regression model. So, why multiple linear regression model? Why do we need multiple, this is in short MLRM, multiple linear regression model. So, why do we need MLRM? That is the question we need to answer first. Why there is a need to understand multiple linear regression model? Now, when our objective is to estimate the impact of education on wage, and if we specify this type of model, then what we assume that the individuals are heterogeneous only in terms of education and they are homogeneous in terms of all other aspects, right. That is why it is only due to a variation in education we observe the variation in individuals' wage. But in reality, individuals are heterogeneous not only in terms of their education, but also many other factors. For example, their ability or skill, their age, their experience, so on and so forth. So, when individuals are different in so many other aspects, assuming individuals are different only in terms of education is quite a restrictive assumption. That means, even if our objective is to estimate the impact of education on wage, we need to include other factors as well in the model so as to control the impact of other factors. Otherwise, your model would be misspecified. And as we have told earlier, model misspecification is a kiss of death. That is how econometrician they call it. And when individuals are different in terms of, let us say, their ability or skill, education, age, so on and so forth, if we do not include those important variable in the model as control factor, then our model will suffer from omitted variable bias. Okay? So, our model will suffer from omitted variable bias. Right? To avoid this omitted variable bias, even if our objective is to estimate only the impact of education on wage, we need to include other factors as control variable in our model. That is what something we have to keep in our mind whenever we estimate any kind of econometric model. So, this is like in pure or natural science, when scientists they conduct experiment, what they do, they do the experiment in a laboratory, and in that laboratory setup impact of other factors are kept constant. For example, if the scientist's objective is to estimate the impact of temperature on gas volume, in the laboratory setup, the scientist will keep the impact of pressure on gas volume, impact of pressure and other factors constant, because that is a controlled environment. So, natural or pure natural experiment are conducted in a controlled environment. You have a you have a control, you know how to control those factors. But when we are doing econometric analysis, basically we are analyzing behavior of the individual, and here the data what we get, it is not experimental data coming out from a laboratory setup, rather what we get is observed data. Okay? So, that means there is a difference between experimental data and observed data. Since we do not have control over what would be the individual's age, what would be the individual's skill, what would be the individual's taste and preference, so on and so forth, when we are analyzing observed data, we need to include other factors also in the model to avoid omitted variable bias, which is not the case in pure science when we conduct natural experiment, because there other factors are automatically controlled in that control laboratory setup. Okay? So, to avoid omitted variable bias, we need to include other factors as well, other factors like ability or skill, then experience, so on and so forth. Okay? And these variables are called control variables in the wage function. Okay. So, that means let us say that our true model would be then wage equals to beta 0 plus beta 1 education plus beta 2 ability plus UI. This is our true model. Okay. We have another variable ability factor that should also be included in the model. If we do not include, then our model will suffer from omitted variable bias. Next, the question is, how do you quantify this omitted variable bias? So, quantification of omitted variable bias. How do you quantify? So, for quantification of omitted variable bias, we will write our true model like this. Let us say yi equals to alpha, or let us say beta 0 plus beta 1 x1 I plus beta 2 x2 I plus ui. This is our true model. And if you estimate the true model, you will get yi hat equals to beta 0 hat plus beta 1 hat x1 I plus beta 2 hat x2 I. Okay. So, that means in this model our wage is determined by x1 I and x2 I, where x1 I is education and x2 I is ability. Now, let us suppose because of ignorance or data non-availability, we specify a model which looks like yi equals to beta 0 plus beta 1 x1 I plus let us say epsilon I. This model we call under specified model. Why this is under specified? Because in the true model we require x2 I also, but because of our ignorance we do not know that ability also matters, or even if you know, sometimes it is very difficult to observe ability and get measurable data. How do you measure individual's ability, which is something, some inert factor, right? Individual's ability is something which is inbuilt and you cannot observe and collect observable data on ability. So, because of that, you might have omitted this variable and you have estimated this type of model yi equals to beta 0 hat. Instead of hat, we will put a different notation, let us say tilde. Since this model is under specified, estimate from the under specified model is denoted by tilde plus beta 1 tilde x1 I. Then the question is, what is the relationship between beta 1 hat and beta 1 tilde? Are they same or different? So, that means the question here is whether is beta 1 tilde same as beta 1 hat. Now, from the relationship of this beta 1 hat and beta 1 tilde, the way we have specified, we can write a simple relationship between these two, where beta 1 tilde is basically equals to beta 1 hat plus beta 2 hat into delta 1 tilde. Okay. If you compare these two model, we can easily understand that this beta 1 tilde is basically this beta 1 hat plus this beta 2 hat and delta 1 tilde. And what is beta 2 hat? Beta 2 hat is basically here beta 2 hat is partial effect of x2i on yi, and delta 1 tilde is basically slope coefficient from the regression of x2i on x1i. That means you can think of delta 1 tilde is basically the sample correlation between x1i education and x2i, which you have actually excluded from your model, right, excluded from your model. So, if you take expectation of beta 1 tilde, what you will get? Expectation of beta 1 tilde would be then expectation of beta 1 hat plus beta 2 hat into delta 1 tilde. This we can write as expectation of beta 1 hat plus expectation of beta 2 hat into delta 1 tilde. Because why we are not taking expectation? Because delta 1 tilde is the sample correlation between x1i and x2i. That is why it would become expectation of beta 2 hat into this, and assuming that beta 1 hat is an unbiased estimate of beta 1 and beta 2 hat is an unbiased estimate of beta 2, what we can write? This would become beta 1 plus beta 2 into this. Then what is the bias? This implies the bias, bias equals to expectation of beta 1 tilde minus beta 1 is the amount of bias, which is equals to beta 2 into delta 1 tilde, right. So, that means the question what we were asking earlier, whether beta 1 tilde is same as beta 1 hat, they are actually not the same, because look at here, expectation of beta 1 hat equals to beta 1 plus beta 2 delta 1 tilde. Now, when they will become, that means when there would be no bias. So, that means the bias would be 0, the bias would become 0. We can discuss two cases. Case 1, let us say that beta 2 is actually 0. If beta 2 is 0, what does it mean? That means ability variable does not actually qualify to be included in the model itself. That means for the population, I hypothesize ability or skill has no impact on wage. If that is the case, then beta 2 equals to 0, and obviously in that case what will happen? Expectation of beta 1 tilde equals to beta 1. So, that means beta 1 becomes an unbiased estimate of beta 1 tilde, which is quite natural. If some variable does not qualify to be included in the model, why should I include that? Obviously, if you exclude that variable also, it does not matter. So, that is the first case. So, beta 2 equals to 0, that means when x2i does not qualify to be included in the model, then your expectation of beta 1 tilde equals to beta 1. Case 2 is important. or interesting. Let us say delta 1 tilde equals to 0. That means in the sample, what does it mean? That means in the sample x1i and x2i are uncorrelated. So, that means even though in the population we hypothesize that some x2i has some impact on yi, and the sample what we collect, we see that education and ability, they are actually not correlated for the particular sample we collected, then also we can ensure that expectation of beta 1 tilde equals to beta. So, under these two cases, either beta 2 equals to 0 or delta 1 tilde equals to 0, then only we can say that expectation of beta 1 tilde equals to beta, that means the bias is 0. However, in reality these two cases, they do not arise, rather we get beta 1 positive and delta 1 hat also not equals to 0. And if that is the case, we can arrive at alternative cases. Okay, alternative cases. Let us say this is case 1. So, how do you write this? Let us say beta 1 is beta 2 positive and delta 1 hat is also positive. Okay. So, case 3, this I will say case 3. So, both are positive, that means the bias amount, if that is the case, in this case bias is also positive. Okay. Bias is also positive. Case 4, beta 2 positive but delta 1 hat negative, then bias would be negative. And case 5, beta 2 is negative and delta 1 tilde is also negative. So, bias is greater than 0. So, these are the alternative cases. These are the alternative cases that we can have. So, this particular example makes us understand the importance of omitted variable bias. So, that means even if our objective is to estimate the impact of education on wage, we should include other relevant factor also like ability. We have taken only one example. If you have many other variables like age, experience, we have to include those variables also, otherwise again your model will suffer from model misspecification. Okay. So, this example nicely explains the importance of omitted variable bias, and that is how they justify the need for a multiple linear regression model even when our research interest is only on a particular variable. This is how we can understand multiple linear regression model.